My name is Ray Brown, RAYBROWN. My title is Director Emeritus at NCAT.
So the video series that we're doing here in conjunction with Napa for Federal Highway, we're going to talk about three main topics. We'll talk about density and durability, we're going to talk about smoothness, and we're going to talk about long life pavements. So we're just going to kind of work through these questions, and if it's a question that you don't feel comfortable answering or you don't want to answer it, we just bypass it and just move on.
Okay.
That's no problem. Talking about density and durability first. Actually, before I get to that, I've been asking everybody just kind of a general type question, but why use asphalt in pavement construction?
Well, about 94% of the roadway surfaces is asphalt. And there are a lot of reasons for that. One is it's relatively cheap to build. It's easy to build. We can do it very quickly, and it provides good performance. Smoothness is another big benefit of the asphalt. So there's a lot of reasons to use it. If we're doing maintenance and rehabilitation, it's much easier to maintain asphalt roads than concrete roads, for example.
Moving into density and durability, can you talk to me, sir, about the relationship between density and improved durability and performance?
Yeah, durability is not easy to define. There's a lot of issues that are related to durability. One is raveling, and some of the cracking that we see would be related to durability. But density is very important to minimize these problems. If we have good compaction, it's going to prevent air from penetrating into the pavement and oxidizing it and making the asphalt brittle. So compaction is essential for durable pavement.
Now, can you speak to what any kind of research that NCAT has brought out about density and durability and what that's meant for the industry?
Well, NCAT has worked with the FHWA on a compaction issue, and they have gone to a number of projects to demonstrate how much compaction a contractor can obtain and to see how much effort it takes to obtain a little additional compaction. And then hopefully these will be monitored over a long range of time to see how this additional compaction has or will affect the performance. So I worked on that initially. It's been going on for 3 or 4 years, and I've since retired. I'm not working on it anymore, but this is a very important project to try to quantify the benefits of compaction. There's been a lot of other studies that we worked on from time to time as well. No particular one comes to mind, but I know we worked on various projects over the years related to compaction.
That's good. So what are some critical things that DOTs need to consider for ensuring optimal density?
Well, we need to make sure we get the air voids in the compacted pavement down below some level. Some say that's 6%, some say 7%, some say 8%. Typical spec now is about 8% or less. And if we do that, it's no longer permeable to air and water, and it's going to make the pavement much more durable. So it's very essential that we do that. It's also essential that we monitor the project during construction to make sure we are obtaining these compaction levels. Without monitoring, we never know what compaction level we're reaching.
So on the contractor side of things, what are some critical things that contractors need to do in their construction practices to ensure proper density?
Well, there's many things that will affect compaction. One is if we have segregation issues, it's going to make it much more difficult to compact. Another is if we don't begin the compaction when the mix is hot, we're not able to reach the required density. Also, we need to roll it in a fairly short period of time to make sure it doesn't cool too much during rolling, that we can't achieve compaction. We also need to make sure that we don't get hairline checking, which sometimes we get with rollers. If we're having checking problems, we need to modify our rolling techniques to minimize any checking.
Now, what are some ways to measure density?
There's two or three ways that we measure density. Some people will use nuclear gauges. Basically, you set the gauge on the surface of the pavement in the backscatter mode, and it will give you a density reading. That's one way. There are also non-nuclear gauges that we can use to measure the density. Both of those are, in my opinion, estimates of the density. The most correct way to measure the density is to cut a core way up in air and water and determine the density that way. We then compare that to the theoretical maximum density to see how well we compacted the pavement.
And what are some ways to provide density quality assurance?
I'll think about that one. Density quality assurance. It's kind of what I said, but go ahead and ask me again.
What are some ways to provide density quality assurance?
Well, we can observe the during the rolling operation to make sure standard procedures are being followed, such as stay close behind the paver, don't make sudden stops and turns, and those kinds of things. Make sure we're not having any checking or other issues behind the rollers. And then we use a nuclear gauge or non-nuclear gauge to monitor compaction with different numbers of passes. And we determine when we reach the density that we're looking for. That way we can set our roller pattern, know how many passes to put on it. But we should always cut the cores to check those to make sure we meet the density requirements.
Now, does temperature affect density?
Yes, temperature does affect density. Matter of fact, we normally heat asphalt 300 plus Fahrenheit, and we have to do that to make it workable and allow us to obtain compaction. It's a whole lot easier to compact during hot weather than during cold weather. It's a whole lot easier to compact when there's no wind than when there's a lot of wind. So anything that will cool the mat off after we placed it is going to make it more difficult to compact.
How do the use of recycled asphalt materials affect density?
Recycled asphalt materials, normally we would use in about 15, 20, 25%, maybe 30%. And the mix is designed to take these recycled materials, mix it with new materials, and basically it looks like new mix. And the compaction procedures are not going to be much different with the recycled mix. We have the same density requirements. Sometimes it might take a little more effort because we're hardening the asphalt in many cases when we add recycled materials to the mix.
What about recycled asphalt shingles?
Recycled asphalt shingles are usually used in very small percentages, 3 or 5%, that range typically. These shingles will tend to stiffen the asphalt and require a little bit higher temperatures to obtain compaction. And so anytime we're using shingles, we've got to watch it very close to make sure we keep the temperatures up but not too hot, and that we stay close behind the paver in the rolling process.
Now, what about warm mix asphalt, and how does that affect getting good density?
Yeah, warm mix asphalt, there's many types of warm mix asphalt, and so it's very difficult to talk about it in general. But what warm mix asphalt will do is allow us to lower the temperature and still compact it. Therefore, we can take the same mix and put it down, and if we have warm mix technology in the mix, we can roll it for a much longer period of time to obtain density. So basically, the warm mix asphalt is going to make it easier to compact and to achieve the density that we're looking for.
That's good. Now, would you say, are there any changes to pavement design and asphalt mixture design that would make achieving consistent density easier for paving contractors?
Well, there are some changes that have made it easier. One, we just talked about the warm mix asphalt. For example, if we use warm mix asphalt technology, it's almost always easier to compact. Another process is SMA, which is a mixture that's a little bit different than a dense graded mixes, but it has high asphalt content, and because of that, it's often easier to compact. We try to put as much asphalt as we can in the mix. without making it unstable. And the more asphalt we can put in the mix, the easier it's going to be to compact.
That's good. So how does new technology affect, improve, or ensure good density?
Well, there's new technology in compaction. We have intelligent compactors now. We have, of course, vibratory rollers that we've used for years and years. We have rollers that will actually vibrate horizontally instead of vertically, and they will help us to achieve density. Anything that will manipulate the materials so that one can pass by the other will aid the compaction process. Also, the intelligent compaction will give us a readout that shows our rolling pattern, how many passes we put on the different areas, and roughly what the density of these areas are. And so it gives us a good idea of if we're achieving compaction or not.
That's good. It's as if you've talked about this a few times.
Well, it's kind of like I got 50 files. It's just which one do you pull out? So sometimes I have to think which one is it wanting.
Yeah. So, and you talked about intelligent compaction here, but I was going to ask you this: if you could describe intelligent compaction as it's used in the construction of asphalt pavements.
Yeah, intelligent compaction was established to basically measure the stiffness of the underlying layers. That's difficult to do with asphalt because the stiffness is affected by the temperature of the asphalt. So it doesn't work really well to determine stiffness, but it does do a good job in giving us a relative density. And so the technology itself is going to give you a reading of stiffness, which is somewhat related to density. There's still a lot of research to be done to help us better quantify that, but we think we can do a fair job now and can do a better job in the future.
That's good. So you just talked about the potential future of intelligent compaction. Let me ask you about this. Are you able to talk about Veda 5?
No.
All right. Well,
Do you know what that is?
isn't that the software? That,
Okay, probably.
And I thought, now forgive me if I'm wrong here, but I thought that was an NCAT developed software for DOTs, but I may be wrong.
That goes with intelligent compactor?
No, I believe it's a separate.
Okay, maybe that's that's probably the temperature segregation, using the lasers to measure temperature right behind the paver. I think we did have some involvement in that, but I'm not. Other than I am somewhat familiar with it being used behind the paver, but as far as the details of the technology, I'm not aware of.
Yeah. Well, one of the guys that work there in CAT, because our trip was cut short because of the accident, we did get a chance to talk to him. But I would like to go back up and talk to him. I don't know if this is his software that he developed, or if it's another piece of software. But he's very, he's the expert. What Buzz was telling me, he's the expert guy to talk to.
Was it Jason Nelson?
Might have been.
Okay.
Might have been, yeah.
Okay.
Well, we'll skip that. We'll move on to smoothness if that's all right.
Okay.
So, talk about smoothness. How does smoothness affect performance?
Well, smoothness is very important because this is what the driving public feels. If it's smooth, they're happy with the road. If it's not smooth, they're not happy. And nothing else much matters to the public. So it's very, very important. And for example, if we have trucks running across the road, if it's very rough, we're going to get some bouncing, and the loads are going to be increased because of the dynamics of the truck. So a smooth road is going to see less stress and therefore should perform better. Also, generally, smoothness is an indication of overall construction quality. If we do a good job of meeting the smoothness requirements, we've probably done a better job of controlling the mix and the project, and so probably going to have better performance because of that.
So how should smoothness, or how is smoothness used or should be used? I had to phrase it correctly. Talk about how smoothness is used or should be used in pavement design.
I'm not sure I can answer that. Yeah, I think that's something I'm not too From a construction standpoint, I know what we do to obtain smoothness. I know that smoothness often is a measure of deterioration of the road, but the details I'm not comfortable really talking about, I think.
Okay, move on then. Should the expectation for smoothness be independent of pavement material type?
Yes, whether we do asphalt or whether we do concrete, the smoothness requirements should be the same. It's only fair to both industries. And if I am a member of the public riding down the road, I shouldn't care whether it's concrete or asphalt, but I should care about smoothness. So smoothness is one thing that I feel, and it's the one thing that we need to make sure we control in both pavement types.
How does smoothness affect dynamic loading?
Well, obviously, if we have a rough pavement, we're going to get some increased loads because of the dynamics of the trucks running across the rough road. So anytime there's a bump, it's going to generate some dynamics in the truck that's going to help to overload the pavement.
And how does smoothness correlate with future rehabilitation needs?
Well, most DOTs will measure smoothness as a measure of deterioration of the pavement. And when the smoothness number reaches a certain amount, then they want to come in and repair it, usually some mill and overlay, but they want to do something to repair the existing surface to make sure that we get it back to acceptable quality.
Can you talk about the role of smoothness in environmental sustainability?
Probably not. I'm not sure on that.
Okay. Then let me ask you this: what factors affect smoothness?
A lot of things will affect smoothness. First thing that affects it would be the way we place it with the paver. Paver needs to be set up correctly. It needs to be moving at a constant speed. It needs to have a constant amount of material that's being fed to the auger and to the vibrating screed. If it does all that, then we get a nice smooth mat behind the paver. Following that, we have the rollers that are going to compact it. And we need to make sure that we roll the surface correctly. We don't have a lot of turns and we don't have a lot of stops. And when we finish, we should have a nice smooth pavement for traffic to use.
Here's a question about DOTs using incentives or disincentives to support building smoother pavements. How should DOTs use these incentives or disincentives to build smoother pavements?
Yeah, I believe that the best approach for achieving smoother pavements is to have incentives or disincentives. If we build a better job than is spec, then we ought to have some incentives. If we don't quite build it up to par, then we ought to have some disincentives. That's the best approach to get a contractor to do their best job on building the asphalt pavement to start with.
What smoothness value do you understand to be good as industry standards for DOTs to adopt?
Don't know that. My experience is more on the construction side. I know we measure with a straight edge, that kind of stuff, and I haven't done a lot of work with when do we repair it type stuff.
So let me ask you this, Dr. Brock. So can you talk about the role of technology in building smoother roads?
Well, certainly there's a lot of things that have affected smoothness over the years. One thing that probably has had the biggest impact on smoothness has been the material transfer vehicle. Back around 1990, this equipment was developed, and it's been clearly shown for the last 30 years or so that if we're using a material transfer vehicle in the construction process, we're going to end up with a smoother pavement. For that reason, many states require a material transfer vehicle on their higher volume roads, such as interstates. I only hit one, but that's the main one probably.
Okay. Is there another one that
Well, that's the main one by far. There's been other things that we've dealt with, but that's the only one I can say much about, I think.
Okay. Some questions on map 21 smoothness requirements, but
Yeah, it depends on what they are, but probably not.
well, one of them is just what are map 21 smoothness requirements?
I don't know that.
Okay.
Yeah. I know what map 21 is, but I don't know what the requirements are.
Okay. So let's move on then to long life pavements. So what are some key factors to ensuring long life pavements?
Long life pavement, we want it to last longer than we normally see in an asphalt pavement. And the industry has spent a lot of effort and time in trying to do a better job of building pavements that last longer. We can do that from a design standpoint. There's perpetual pavements. Been a lot of effort in designing and building perpetual pavements. These pavements last longer. There's also been improvements in materials. For example, we mentioned earlier stone matrix asphalt. That's a material that should give us longer life. And so there's several things with materials that we can do to give us longer life. Maintenance, if we have issues, early maintenance can give us longer life as well. So we should do all that we can to build longer life pavements to get better life cycle cost.
That's good. What are the fatigue endurance limits that define modern long life pavements?
I got to think what the number is. I did some work on that. Well, I don't remember the number, so all I can do is talk generally about it. But I can talk generally about it.
Okay, sounds good. So I'll ask you this then. Talk about fatigue endurance limits and how it works with modern long life pavements.
Yeah, fatigue of our pavements has been a big issue. As we put more and more traffic on it, we're going to get earlier cracking and more cracking. So anything that we can do to reduce fatigue is a good thing. One of the things that we can do is to identify the endurance limit of our pavements and try to keep the strains below the endurance limit so that we don't get early cracking. We can do that by improved materials. We can do that by increased thicknesses. We can do that by better construction. So there's a lot of ways that we can change the endurance limit to give us better life. And we need to look at the ways that we can do that.
That's good. Now, how do these fatigue endurance limits change depending upon types of materials?
Well, the endurance limit is a point at which we're going to get no damage in the asphalt pavement with increased loads. And so what we've got to do is determine for each mix what that endurance limit is. If I have a mix with relatively high asphalt content, it usually has a higher endurance limit. And so if I use that mix, I should be able to make the pavement last longer, everything else being equal.
I was wondering if let's see now, this may or may not be something, it's an NCAT question, but it may be, it's about Per Road that was developed.
Yeah, I know Per Road, but that's about it. There's Dave Tim. Did you meet with him?
No, and that might have been the gentleman I was referring to.
Yeah, Dave Tim is the guy that developed Per Road.
Yeah, we unfortunately weren't able to meet with them.
And there's other guys that can talk about it, but.
Well, I might reach out to them, and since we're just down in Panama City, throw a camera, a light in the car, drive up, and talk to him for a little bit if he's got time.
Okay. Well, he would be the best, Dave Tim.
Okay. I'll reach out to him and see if that's possible. Okay, so this is about AASHTO pavement ME.
Dave Tim would be the best guy.
Okay. Let me ask you this: what requirements should DOTs write into design standards in order to assure long life
Well, there's a number of things that we can do in the design standards to ensure a long life pavement. One is improved density requirements, higher density. One is improved asphalt binders. For example, there's different grades of asphalt binders, and some of the higher grades that have polymers in them perform better. There's aggregate quality. We can specify improved aggregate quality, and all these things will give us improved performance. We just have to make sure that the cost for the performance is below, is not too high.
So how does the long life pavements approach change the design paradigm?
Well, one thing that we do from a design standpoint is there's we usually assume that the cracking starts at the bottom of the pavement. So there's some discussion about using a richer asphalt mix, one with higher asphalt content at the bottom of the asphalt, which would be more fatigue resistant. And then just above that area, we can use a stiffer asphalt that's maybe not quite as fatigue resistant, but it's more resistant to rutting. And so as you get closer to the surface, you need something that's more resistant to rutting. And by combining these two approaches, we can get a pavement that will have much longer life.
And how would you say that long life pavements factor into state agencies' capital investment?
Well, the problem that most states have, in my opinion, is that they look at first cost. And the problem is most of the elected officials are in for 3 or 4 years, and almost anything we do will last 3 or 4 years, and that gets them into the next person that takes over. So there's a lot of emphasis on keeping the initial cost down. But if we look at the life cycle cost, long life pavements are going to be cheaper in the long run. So we've got to, instead of looking 3 or 4 years down the road, we need to look 25, 30 years down the road. And then we can clearly see that if we build longer life pavements, we're going to get a lot more for our money.
That's good. I got 2 more questions.
Okay.
The first one is about, well, this is the SMA conference, Stone Matrix Asphalt
Yes.
Conference. What is the role of Stone Matrix Asphalt in long life pavements?
Yeah, Stone Matrix asphalt began to be used in the U.S. about 1990. And the reason we first began to use this is we were looking at ways to reduce rutting. 30 years ago, we had significant rutting problems. And most of the ways that we would reduce rutting caused more durability problems. So we would help one, but we'd hurt the other. SMA gives us the opportunity to put a mix down that is more resistant to rutting and also more durable. It has high asphalt content, but it has large coarse aggregate content and a very strong asphalt matrix that makes it perform well in rutting and in durability and in fatigue.
That's really good. So the last question really is about NCAT. And I know Dr. Bryan has been involved in NCAT for many, many years. And still, even in your retirement, have a role. So can you talk to me about the partnership that NCAT has, say, with, and not specifics, but describing the working together between organizations like NCAT, state DOTs, and contractors, and how those partnerships benefit the industry as a whole?
The asphalt industry is made up of several key groups. We have the asphalt contractors, we have the DOTs, we have Federal Highway Administration, we have researchers, and NCAT has been able to work with all of these to pull them together to help address questions that each of us have. States have different problems than contractors, but we all have problems. And if we can identify these problems and identify the problems that we have with mixes, together we can work and solve these issues and build better pavements that are going to last longer for all of us.